Assalamu alaikum everyone. This is our first lecture for Module 1, Week 1. The Module 1 is talking about computer programming basics. In Week 1 we are going to talk about computer systems overview, and the course learning outcome to be covered within this module is going to be the applying the input and output instructions in writing C++ programs. Now, the module will consist of 3 weeks. In these 3 weeks, we are going to cover computer system introduction, binary systems, data types, and finally we are going to cover the programming variables. Now, as you all know, a computer system consists of the motherboard. The motherboard, as you can see, is this board over here. Now, this board will contain all the components. If you open a motherboard of a computer, you are going to find the CPU, which is this part over here, and your memory over here. And between them, we have the buses. Now, the hardware, as we see, we are talking about CPU, we are talking about memory, and storage devices. Okay, CPU. What do you know about the CPU? So if I tell you go and buy a computer, go to the market and buy a computer, which CPU should I choose? Should I choose the i3, the i5, i7, i9? Which one? Should I go for Intel or go for AMD? Now, when I talk about memory, what is the memory? What is memory? What do you mean by memory? I know most of you now, if I ask you how big is your memory in your phone, you will tell me, doctor, we have 64 gigabytes, right? طيب, how much RAM? How much RAM do you have? And why is RAM important? We are going to cover all these topics. And finally, the storage devices in the computers. After that, we are going to branch out and talk about the operating systems, applications, and utilities. This is all we'll be covering during this week. Now, this is the CPU chip. Okay, so this is our CPU chip. How big is it? If you think about it, if you know the 50 besa, the CPU chip is almost the size of 50 besas. It's that small. Don't look at this picture over here. This one is zoomed in. The CPU is around 50 besa size. Of course, the price is not 50 besa. So the CPU is called the brain of the machine. The brain of the machine. It will do everything. Now, the circuitry performs arithmetic and logic operations. What do we mean by arithmetic? What is arithmetic operations? Anyone knows? Arithmetic operations are addition, subtraction, multiplication, and division. How about logical operations? What are the logical operations? We have and, or, and not. These are the basic operations. We are going to study all of this during this semester. No need to rush, but this is just an introduction. Now, CPU measurements. So I will go and buy a new computer. The guy will tell me, okay, sorry, I have to go back. The guy will tell me, okay, your computer is running at 2.1 gigahertz. What does 2.1 gigahertz mean? This is the frequency. And yes, what we want is to have fast computers. First of all, how much is giga? It is 10 to the power 9. So my computer can execute approximately 10 to the power 9 instructions per second. You know 10 to the power 9 is how much? That is 1, beside it 3 zeros, 3 zeros, and 3 zeros. This is how big it is. This is how big the number is. This is 1 billion instructions per second. Now, to put things in the right perspective, you have a CPU having 8 cores. 8 cores. Each core is running at 2.5 gigahertz. So your computer, your computer will have 2.5 gigahertz, around 1 billion instructions per second per core, and you have 8 cores, so around 8 billion instructions per second. Now, examples of CPUs. Intel i3. You go and buy a computer, you are going to find a lot of computers from Intel, right? So I will go to the shop, I want a laptop. They tell me, okay, you want i3 or i5 or i7 if you have a lot of money, or you require, you can even get the i9. Now, after this, it's not the whole story. He will ask you which generation. Now we are in the 10th generation nowadays. So if I go and buy a computer, I am going to ask for an i5 or an i7 10th generation. Okay, don't go for something less than that. We have AMD with their Ryzen 5 series. We have the Snapdragon 865. Anyone knows where is the Snapdragon located? Think about it. We will leave this for discussion. Where do we find Snapdragon processors? So the main memory, which is the RAM, is a memory which is fast but volatile. What do we mean by volatile? Okay, I have a question mark here. What do we mean by volatile memory? What is volatile memory? Volatile memory means if power is off, data is lost. This is the reason why when your computer is stuck, what we will do, restart. And once we restart, what will happen? All the data will vanish, will disappear. So RAM is a fast memory and is volatile. Each location is called a bit. Each 8 bits are called a byte. Each 10 bytes are called kilo. Each 2 to the power 10 bytes are called a kilo. Each 2 to the power 20 are called mega. And this is how the RAM looks like. Secondary storage. Secondary storage, first of all, that one was called primary. Primary يعني أولي. Secondary يعني ثانوي. Secondary storage. Secondary storage is the place where we store our programs for safekeeping. First of all, it is a non-volatile memory. يعني if I power off my computer, data in my flash drive will still be there. Anyone know what's this? Any idea what is this? This is an M.2 SSD, solid state disk. This is a normal hard drive, HD hard disk we call it. This is a Blu-ray, and this is normal CD, and this is our old friend, the floppy. Now let's start from floppy. Anyone knows the size of the floppy? The size of the floppy is around 1.2 megabytes. Mega should be capital. Okay, the size of the CD-ROM. 700 megabytes. The size of the Blu-ray, where can we find the Blu-ray? Size of the Blu-ray around 40 gigabytes. The Blu-ray. Okay, where can we find it? Very famous. PlayStation 4 or Xbox. All the gaming consoles are using Blu-ray CDs. That's why the price is expensive. Hard drives. Hard drives, you can find them now in terabytes. And SSD, terabytes. You can go and buy your laptop, new laptop. They will tell you it has a 256 gig SSD or 512 or even 1 terabyte. Flash drive depends on how much you are willing to pay. You can find nowadays 64 gigabyte for a reasonable price. Now, input and output devices. So input devices are instructions and data must be encoded into binary form to transmit it to CPU. Now, if I'm going to use an input device, which is an audio device, which is my microphone I'm using now here, my voice is going out as sound waves. I need some transducer to change these sound waves into digital signals 0 and 1. So this transducer is my microphone. This transducer is my microphone. Same applies for the scanner. It will change the picture to an image on the computer. The joystick, the one we play PlayStation with, the joystick changes the movements into electronic waves for the computers. So these are called all input devices. Output devices, on the other hand, they do the other way around. They change the digital into real world values like the sound, the video, monitors and printers. All of these are output devices. Now we have the cache memory. Cache memory. You will say, doctor, what is cache memory? Where do I find my cache memory? Okay, let me take you in a small tour. So on my computer, I'm going to go for my task manager. So my task manager, if you see over here, this is my task manager. I will go for performance. This is my computer. It's an i5 825 CPU. It's an 8th generation. Okay, 8th generation. If it starts with an 8, it's an 8th generation. If it starts with a 9, it's the 9th generation. If it starts with a 10, it's the 10th generation. It runs at a speed of 1.6 gigahertz. This is the base speed. If you run turbo, the speed here will go higher up to 3 gigahertz. You can see here I have 8 cores, in which 4 of them are actual cores and 8 are logical cores. This is my cache memory. Okay, you can see here I have L1 cache 256, L2 cache 1 megabyte, L3 cache of 6 megabytes. Now, why do we need this cache memory? Story is simple. The story is we have our the pen. Okay, we have our hard drive. It stores our programs. We have our CPU. So the CPU needs the data. This one is very slow. So instead, what do? We put the RAM in the middle. All the data will go from the hard drive into the RAM. RAM will be connected to the CPU. However, RAM has become a little bit slow. So what we did is we added the cache memory. Now the cache memory, let me fix it. The cache memory, as you can see here, okay, the cache memory is sitting between the RAM and the CPU. All of these lines are bidirectional. Okay, the cache memory is sitting between the RAM and the CPU, and the main purpose of this cache memory is to make things faster. So access speed of RAM faster can accessing secondary storage. However, it's still quite slow. That's why we need to add the cache memory. Now, this is not the full story. Nowadays, there is something called Optane memory. The Optane memory sits between the cache and the CPU, or basically the Optane memory can be a solid state cache. Okay, so something new from Intel is called Optane memory. Now the assumption are these. Now the cache, before going to the assumption, the cache, as you saw, it's very small, around 1 megabyte. Okay, around 1 megabyte. If it's 1 megabyte, how am I going to store all this information in the cache? Solution is easy. I will not store all the information from the RAM. I will choose the most commonly used instructions and put them in the cache. If something is going to be used a lot, put it in the cache. The CPU will get it faster. So that makes things easier to choose which instructions we are going to use in the cache. This is a totally, it's a total science, the cache. So we will be discussing this more in fundamentals of computer systems if you are going to study computer and electrical and computer engineering. So our hardware summary, to put things in the right perspective. We have secondary storage holding our applications and OS. What's an OS? It's our operating system. Okay, so OS is our operating system. Our main memory, which is our RAM. Sorry, my spelling is wrong. So our main memory is our RAM. Now our RAM will be holding all the temporary data that we are going to run in the computer. So this is our RAM. And this is our cache memory. Everything is connected through buses. So the operating system, or OS software, it is loaded from the secondary storage into the computer. This is the story where you see every day. You power on your computer and you start seeing these dots moving right on your screen. This is the time for loading the operating system from the hard disk into the RAM. Now, once the operating system is loaded into the RAM, the operating system starts managing the hardware and it provides an interface for the user. Now, again, we go back to the RAM. Why is RAM important? If you have larger RAM, then you can hold the operating system and multiple programs. If you have less RAM, this means you are going to hold less information in the RAM. So examples, we have the Mac OS, we have Windows 95, Windows NT, Linux. Of course, we have the famous Windows 10, and we have the iOS for the iPhones, and we have the Android operating system. Software applications, examples, we have non-operating system software applications such as Word, spreadsheet, database, web browsers, and C++ compilers. Since this course will concentrate on C++ compilers, we are going to talk a little bit about compilers. We have the GNU C++ compiler. This is for Unix or Linux. Anyone know what's Unix or Linux? These are open source. This means, بين قوسين, free operating system. We have the turbo and Borland C++, and we have the visual C++. User programs, which are programs that neither the operating system nor the applications, which are called user programs. This is what we are going to write during this semester. I will end up part 1 over here, and I will meet you again in part number 2. Hope you gained information, good information in this lecture. Thank you all, and I will be seeing you soon.